Welcome to educational channel. So this video is about linear inequations for class 8 ICSE board maths. So I'll explain you complete topics in this linear equations including some problems. Before problems, I'll explain you the properties of inequalities also. So let's see one by one. And apart from that, and before going to start this topic, so let me show you website here so you can see foundation for IIT.com. So this link is in description below. You can find out all the information for class 6th to 12th. So chapter wise, including topic wise also, assignment test papers and model papers, and each and every solution for every question also is available. Just you can go through it. And subscribe the channel because we'll upload only the videos which are related to education. So this is the channel name. You can see in this, right? Okay. And let's see this topic first. Linear inequations. So this is about inequality. So generally this is equal symbol. So like 2x is equals to 4. So this is equal symbol. Apart from this equal symbol, any other symbol if you write, a statement of inequality between two expressions is called inequation. So 2x plus 3 is an expression and 4y is an expression. In between we need to keep some inequality symbol. So there are less than, greater than, less than or equal, greater than or equal, or not equal. So these all come under inequalities only. So this is less than, and next one is a greater than. And this is less than or equal, and greater than or equal, and this is a inequality, inequation. So unequal. These symbols will apply in inequations. Okay, for example, x is greater than 17. That means x value is more than 17. So 18, 19, 20 and so on. And what is x belongs to? Either x belongs to natural number, or x belongs to whole numbers, or x belongs to integers. Based on that also we can write the solutions. So we can conclude that a statement of inequality between two expressions. So between two expressions is called a inequation, right? Now linear inequation. So what is linear inequation? So a statement of any of the form like, so when you see the linear inequation, so previous topics you already learned about linear equations. Now same, linear is nothing but is having only order is 1, so highest power is only 1. Okay, there are any form like ax plus b is greater than 0, or ax plus b less than 0, ax plus b is greater than or equal to 0, and ax plus b is less than or equal to 0. So any one of the form. So some a and b are constants here, x is a variable. So here a and b are the real numbers, and a is not equal to 0. So a should not be equal to 0. Is called a linear inequation in x. So in terms of x. So these are the linear inequations. And when you see replacement set and solution set, I'll explain you now. So what is replacement set or solution set? First, replacement set, or we can call it as a universal set also. Universal set. And one more, okay, other side, and solution set. Okay, let's see what is the difference between them. So in inequations we'll follow. So replacement set is nothing but from all the values of variables x are chosen as to satisfy the given condition or given inequations. It's called replacement. I'll explain here. For example, natural numbers. So from 1, 2, 3, so on till infinity. So in equation I am taking x is less than 4. So this is a inequation. Now natural numbers, all the natural numbers are universal set. So in this only we should write solution set. So from this all the natural numbers which satisfies this inequation x is less than 4. So in x is less than 4 are only 3, 2, 1, because 0 minus 1 also less than 4, but they are not from natural numbers. Now this is a solution set. So this is a replacement set. From this we can replace for solution. Okay, replacement set or universal set. From this, to satisfy this given inequation, whatever the values you'll write, that is a solution set. Okay, any other example also you can take. So universal set and replacement set. For example, x is greater than minus 2 and set A, taking some values 1, 2, 3, 4. So when you see, this is if it's take a universal set, from this solution set x is greater than or equal to minus 2. So these all are greater than minus 2 only. So everything is also solution set now. So your universal set and solution set are both are same. For example, set B is given minus 4, minus 3, minus 2, 1, 0, minus 1, 0, 1, comma 2. Now if this is universal set, so it's a given set, in this solution set which satisfies the given inequation, this given inequation, x is greater than minus 2. X is greater than minus 2 means x value should be more than minus 2, that is minus 1, 0, 1, 2. So this is only solution set, minus 1, 0, 1, comma 2. So solution set, right? So that is the difference between linear replacement set and solution set. So the set from which the values of variables x are chosen so it satisfies the given inequation is called universal set. When you come to solution set, this is a subset of replacement. So from this is subset and consisting of all the values which satisfy the given equation. Given inequation satisfy only, there is a solution set. You can see the examples also based on this. Anything, not only this. For example, find the solution set. For example, question, find the solution set is asking. Okay, if you take, so find the solution set x is less than or equal to minus 3. The replacement set B is equals to minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. So from this I need to write the solution set. Then solution set is nothing but which will exactly satisfies the given condition, that is x is less than or equal to minus 3. So x is less than or equal to minus 3 is x belongs to this set B. In that x is less than minus 3, less than or equal to minus 3, that means we can write only which are less than minus 3 is minus 6, minus 5, minus 4 and minus 3 also, because here when you observe this is less than or equal, so minus 3 also should take. Minus 3, minus 4, minus 5, minus 6, these are the less than minus 3 you can take. So that is the universal set and solution set, because solution set is a subset of universal set we can take. Right? Now I explain you the properties of inequalities, what the properties we can use. So let us see now. Properties of inequalities. So let me show you some properties of inequalities. There are 6 important properties. So I'll explain you one by one. First one, adding the same number to each side of the inequality does not change the inequality. So if for example, that one, adding the same number, adding the same number, if you add any number, each side of the inequality does not change the inequality. So you can't change any values. For example, 3 is greater than 2, right? If 3 is greater than 2, adding same number on both sides. So if you add the both sides same number, for example 3 is greater than 2, I'm adding, okay, plus same number should add, I'm adding number 9 both sides. Then 3 plus 9 is 12 and 2 plus 9 is 11. So 12 is greater than 11. So value, inequality will not change. So adding the same number to each side of the inequality does not change the inequality. Okay, that is first one. If you add any number same side, it will not change. Not only this adding, means negative number also you can add the same. For example, 16 is less than 20. Now 16 is less than 20. I am adding both sides, minus 2 and minus 2. 16 minus 2 is 14, 20 minus 2 is 18. Yes, so 14 is less than 18, so value not change. So adding the same number on both sides, value not change. Now second property, this is the first one, and when you see second, subtracting the same number from each side of the inequality also does not change the inequality. Subtracting same number from each side. Even if you do subtracting the same number on both sides or each side of an inequality does not change the inequality. So let's see example. Otherwise that means if for example A is greater than B. If A is greater than B, then actually A is greater than B. I'm subtracting both sides minus C. So A minus C is also greater than B minus C. We can write. And if A is less than B, even then A minus C is less than B minus C. Okay, if it is A is less than B, then A minus C also less than B minus C. You can see example here. Okay, we will take some value. Now minus 8 is less than plus 2, positive 2, right? So I need to subtract the same number both sides. Now minus 8 less than 2, and both sides I have to subtract the same number. Now minus, I'm taking minus 4, minus 4. So both sides I am subtracting 4. Now 8 minus 4 is minus 12. 2 minus 4 is minus 2. Yes, so minus 12 is less than minus 2. This is also true. Okay, that is the second rule. Subtracting the same number from each side, so it does not change the inequality, right? Now multiplication process. So the third property. There are 6 properties. So this is the third one now. This is multiplying each side of inequality by positive number. Okay, multiplying each side of an equation by some positive number. If you multiply both sides with positive number also does not change the inequality. So this is important here. Positive number, multiplying the both sides only with positive number. So see here. That means for example 6 is greater than minus 2. So I am multiplying both sides with positive number. 6 is greater than minus 2 is given. I need to multiply with some positive number into, take plus 4 and plus 4. Okay, positive number. You can check this rule. 6 4s are 24 and minus 2 into 4 is minus 8. Yes, obviously it's correct. 24 is greater than minus 8. So multiplying each side only with the positive number does not change. So does not change the inequality. That is one. And in the same multiplication case, you see the important property here. This is most important. Multiplying each side of inequality by negative number. Okay, multiplying each side of an equation an inequation by negative number. Negative number, then reverse the inequality. Okay, so most of the cases, many few students will do mistake in this, multiplying each side by negative number. So let me show example. For example, if you take a is greater than b, okay, if a is greater than b, and one sees one number that is less than 0, that means negative, then a into c and b into c. If I multiply, then instead of greater than, we should keep less than symbol. So ac is less than bc. And similarly, if a is less than b and c is a number that is less than 0, then same ac and bc. It is a is less than b, right? So ac is greater than bc. Okay, I'll explain you with examples. So let's see the example now. So I am taking first a is greater than b. Now take 3 is greater than 1. Okay, 3 is greater than 1, we know it. Now take one number, it should be less than 0. So I am taking minus 2. Minus 2, I need to multiply both sides. Now 3 is here and 1 is here. Both sides I need to multiply with negative number. So negative number is here, minus 2. If we simplify this both, 3 into minus 2 is minus 6, 1 into minus 2 is minus 2. Now you tell me, minus 6 and minus 2. So minus 6 itself is less than minus 2. Okay, in the place of greater than, this becomes less than. And see one more example. Okay, take one. For example, minus 2 is less than plus 4. Okay, we know it, minus 2 is less than plus 4. Now minus 2 less than 4, both sides I am multiplying with some negative number. So take any negative number. Okay, taking minus 9, minus 9. See here, minus 2 into minus 9 is plus 18, because minus 2 minus plus. And 4 into minus 9, that is 36. Minus 36. 18 and minus 36. So obviously 18 is greater than minus 36. Okay, this is important rule. If you multiplying each side of the inequation with a negative number, then reverse the inequality. You should reverse the inequality. First, adding, subtracting and multiplying with the positive numbers, there is no change. But multiplying each side with the inequation with the negative number, then you need to reverse the negative rule. Fine. Now, see here one more, fifth one. This is about the division. Divide each side of inequality by positive number also does not change. Same like multiplication. Divide each side of an equation with a positive number. With a positive number, if you divide with each side, there is no any change. So if a is greater than b, and for example c is greater than 0, then a divided by c is greater than same b divided by c will come. If then, see example, 4 is greater than minus 8. So take one positive number. I'm taking 6. So take the 6 and divide. Take 6 and divide by 6 and by 6. 4 by 6 is 2 by 3 is greater than minus, this is 4 by 3. Yes, so obviously 2 by 3 is greater than minus 4 by 3. And in case, the sixth one, this is with the positive number we are dividing. And one more property, dividing each side of an inequality by negative number. So if we divide by negative number, same how we did in multiplication, we need to reverse the inequality. Okay, reverse the inequality. We need to change. Now see here, Example, 9 is greater than positive 3. Okay, 9 is greater than 3. Now we need to divide both sides with a negative number. So negative number I am taking -6 and with -6. Now if you simplify this, this is 3 2s are 3 3s are, so it's -3/2, and this is 3 1s are 3 2s are, -1/2. So in case -3/2 is actually less than -1/2. Okay, because denominators are same. -3 is less than -1. Okay, fractions if you can change also you can say. So this is nothing but if you can cancel 2, -3 is less than -1. Okay, see one more example which is easy for you. Okay, taking 16 is less than 40 and divide with a negative number both sides. So I am dividing with negative number both sides, like -2 -2. So 16 by -2 is -8, 40 by -2 is -20. But -8 is greater, right? -8 is greater than -20. So these are the 6 important rules. And adding, subtracting, there is no change. But multiplying and dividing with a positive number also there is no change. Only multiplying and dividing with a negative number, we need to reverse the inequality. These are the important rules. These are the important properties of inequality we need to follow for solving the problems in inequations. Okay, then I'll show you some problems. So how to represent the solution set a number line and solving the problems of inequalities also using this property. So I'll explain now. So here how to represent the inequation solution set on number line. So before doing this and before understanding this how to solve and how to represent a number line, we need to know some notations. So generally we shall be using the following notations. Capital N. So this is a set of all natural numbers, right? Set of all natural numbers. Because I'll mention this later. Set of all natural numbers is capital N and capital W. This is set of all whole numbers. So they start from 0 and natural numbers start from 1. You can call them as counting numbers also. And capital Z. So this is the set of all integers. And Z plus and Z minus. So Z plus means this set of all positive integers. Okay, positive integers. And Z minus, if we keep, this is set of all negative integers. And one more is a Q. This is a set of all rational numbers. So rational numbers. These notations will apply in this solving, representing the solution on number line. So let me show you one question here. So see some problems. First one, find the solution set of 3x plus 4 less than 15 and x belongs to capital N. So x belongs to natural numbers now. So they'll mention like this. So we need to understand what is N, W, Z, Z plus, Z minus and Q. So N is the natural numbers. From all the natural numbers are universal set. From this you need to find out only solution set that we should represent on number line. So here we have 3x plus 4 is less than 15. Now to solve this we need to find out only x values. So it's a plus 4. So first up on subtracting 4 from both sides. So 3x is less than 15 minus 4. So this is 4 is removed, plus 4 is minus 4. So 3x is less than 15 minus 4 is 11. And divide 3 both sides. So x is less than 11 by 3. 3 into x it become divide. X is less than 11 by 3. So from 11 by 3 that means we can write in mixed fraction. X is less than, in mixed fraction is 3 2 by 3. Okay, 3 is a 9, 9 plus 2, 3 2 by 3. X is less than 3 2 by 3. So that means more than 3 it is actually. X is less than 3 means here from this solution set we can write. Okay, solution set is, that is 1 2 3, because natural number starts from 1, 2 and 3, because x is less than only 3 2 by 3. So 3 point something it is. So it's 3 also you can take 1 2 3. Now this solution set can be represented on number line by making some black circles at points marked at 1 2 3. Okay, you can take a straight line. So when you keep arrows, this is a line. This endpoint, there's no endpoint, it's a line. We can make it. So we can mark the points. With equal distance, we need to mark. So 0, 1, 2, 3, 4. Right side is increase the values and left side is decrease the values. Okay, this is a set of integers. In this only natural numbers 1, 2, 3. Only 1 itself. So we can circle this 1, 2 and 3. So just to only make the black circles. Just you have to make the black circles at the points marked 1, 2, 3 as shown here, right? So this way you have to represent the solution set to number line. This is only for natural numbers. So natural numbers and whole numbers also you represent with the circles, and rational numbers is different. So I will show one more example also. So let me show you one more question. So your problem is solve 3 minus x is greater than minus 2, and x is belongs to here also natural number. First you'll find out the solution set, then we can represent. Okay, when you see 3 minus x is greater than minus 2, right? So we need to find out only x value. So see clearly here, 3 minus x is greater than minus 2. This is plus 3. So we need to subtract minus 3 both sides. That means we should add the minus 3 both sides. So actually this is plus 3 greater than minus 2. That means minus 3 original. So minus 3 plus 3 cancel. That is x is greater than minus 2 minus 3 is minus 5. So by adding minus 3 on both sides, we got only minus x. Now multiplying both sides with, this is minus x. So minus 1 into x. So we need to multiply minus 1 both sides. So according to the multiplication rule, minus x is into and minus 5 into. I am multiplying with negative number both sides. So negative number. So whenever you multiply with a negative number, then interchange the sign. The inequality, or change the inequality rule. That is, greater becomes less. Okay, this is rule number 4 I explained. So minus x into minus 1 is plus x, less than minus 5 into minus 1 is plus 5. So x is less than 5 now. X is less than 5 and x belongs to natural numbers. So we can represent on number line. So 1, 2, 3, 4, 5 and 6. So it is 0, minus 1. So we need to, because x is belongs to natural numbers, so we should use the black circles. X is less than 5. So not even 5 also. So that means 4, 3, 2 and 1. That's it. 1, 2, 3, 4. So solution set is 1, 2, 3 and 4. So the black circles, you just bubble it. Bubbling we should do. So black circle you make. That's it. So this here is the important rule is this one. When you multiply the negative sign both sides, you should change the inequality. Okay. So with some integers, I'll show one more question here. When x is belongs to integers, how to solve? Find the solution set for 15 plus 6x greater than 0, and x belongs to integers. So represent the solution set on number line also. There's a question. We should represent on number line. We need to find out the solution set. Both we should do. So question is 15 plus 6x greater than 0. So it's a plus 15. So add negative 15 both sides. That means 6x is greater than minus 15. Okay, same symbol. And divide the positive number both sides with 6 because 6 into x it is. So if you divide with the positive number both sides, they become by 6 and by 6. 6 cancel. So x is greater than minus 15 by 6. So you can write in mixed fraction minus 15 by 6. 15 divided by 6. Okay, 6 2s are 12, remainder is 3. So we can write in mixed fraction like 2 3 by 6. That is 2 1 by 2. X is greater than minus 2 and half. That means x is greater than minus 2 and half. So we can, so solution set is, now this is the value of x. So solution set, so we can write like this. That means x belongs to integers because x is greater than minus 2, there is infinity. So x is greater than minus 2 1 by 2. To represent, that means this is in set builder form, and when you write in roster form, minus 2, minus 1, 0, 1, 2 and so on. So the infinity because x is greater than negative 2. When we are represent, we can represent this solution set on number line as like this. So take a line. Anything is like infinity, infinite type, we can use the same, but we need to apply some dots. So I'll show here. Okay, minus 3 I'm starting, minus 3, minus 2, minus 1, 0, 1, 2. We can maintain the same gap, so it looks very neat. 5, 6 and so on. So we need to represent with black dots, black circles. So minus 2, so it's minus 2 also is there. So minus 2, minus 1, 0, 1, 2 and so on. That means even 3, 4, 5, 6. So it's still infinity. So in that case we need to just keep 3 small circles, bubbling circles you can keep. So this meaning is, so there's infinity. So it's not ending up to 6. It's even 7, 8, 9 till infinity. So there's a meaning of this. You can keep the, so 3 dots on right hand side show that the making continue on right hand side up to infinity. If you keep this like 3 dots for left side, so it's continue for left side, the negative numbers. Okay, in this way we can represent so any solution set on number line. And to do this we need to find out the value of x first. After getting solution set we can represent on number line. And further you need to remember this notations. Then we can apply which values we need to take, either natural numbers from or whole numbers, integers, even negative, positive integers as well as rational numbers. Okay. Now only when the solution set is given, apart from number line, only to find out the solution set, some more sums are explained now. So here I will show you some problems which are related to inequations and few sums I will explain you. So based on that, according to the same pattern and same method, you can solve the similar sums also. Fine. So few questions I will explain you first. Solve 5 minus 4x less than x minus 10. So x is belongs to is on universal set is given. Here is 0, 1 up to 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. So from this we need to solve the values of x. Okay. Now we need to find out the value of x first. Then when you take 5 minus 4x less than x minus 10. Same in equations. So the problems based which are related to equations, how we solve, same way. In case the properties you need to apply. So when you multiply negative number both sides only, you should interchange. When you divide with the negative also, we should interchange the inequations. Apart from the remaining all, just we can change as this. Okay, first adding negative 5 both sides. So I'm adding negative. So adding and subtracting, there is no any change. That means minus 4x less than x minus 10 minus 5. Okay, this is a plus 5, right? When you take other sides, negative 5. Then minus 4x less than x minus 15. Okay, minus 10 minus 5 is minus 15. Now this is a positive x. That means we can take minus x both sides. So minus 4x minus x less than minus 15. So two ways. This is a positive x. It becomes minus x. Minus 4x minus x is minus 5x less than minus 15. Now when we multiply with minus 1 both sides, we should change the sign. If you observe here, minus 5x and minus 15. I am multiplying with minus 1 both sides. So this is less than becomes greater than. Only in this case. Minus 5x into minus 1 is a plus 5x greater than minus 15 into minus 1 is a plus 15. So x is greater than 15 by 3 divided by 3 divided by 5 both sides. So x is greater than 3. X value is greater than 3. Now in this values, x is greater than 3 is only 4, 5, 6, 7, 8. Okay, that is a solution set. Therefore, solution set is greater than 3, only 4, 5, 6, 7, 8. Because given set is, the given universal set or replacement set is only up to 8. Okay, this way you can solve. And one more sum. If there is a two inequations in between, see how to solve. The question is solve 11 less than 4x plus 1 and less than or equal to 21. Here x is belongs to integers. Okay, the notation you remember. 11 less than 4x plus 1 and less than or equal to 21. So we should take up 2 separately, like first 2 and last 2. That means, so observe here, two ways we have to do. Step 1, case 1 and case 2. That is taking case 1 here, 11 less than 4x plus 1. So first two sets, first two expressions, right? And next two expression is, that is 4x plus 1 less than or equals to 21. So we shall take up 11 less than 4x plus 1 and 4x plus than less than 21 separately we should take. Then you can solve separately as it is. That is plus 4x. Now if we take left sides, minus 4x less than this plus 11. If you take this side, minus 11. Only plus 1 is here. Minus 4x is less than minus 10 because minus 11 plus 1. Now changing the negative sign both sides. That means it becomes 4x is greater than plus 10. Okay, this you remember. Multiplying minus 1 both sides, negative. And x is greater than 10 by 4. So x is greater than, this is cancelled, 2 2s are 2 5s are. 5 by 2 is 2 and a half. 5 by 2 is 2 and a half. X is greater than 2.5. So 2 and a half means. Now we need this part. So finally x is greater than 2.5. This is one case. Let be equation 1. In equation 1. And 4x plus 1 is less than or equal to 21. So it's plus 1, right? So minus 1 both sides. So 4x less than or equals to 21 minus 1. When you take this plus 1 right side, minus 1. You can take like that. 4x less than or equals to 21 minus 1 is 20. And divide by 4 both sides. Then x is less than or equal to 20 divided by 4. Okay, this 4 into x. So you can take right side is divided by 4. X is less than or equals to 5 because 4 ones are 4 5s. Let me second one. So when you observe both, x is greater than 2.5 and x is less than or equal to 5. X is greater than 2.5 means 3, 4, 5, so on, but x is up to less than 5 only. These two conditions satisfying, we need to make for both. So let solution set for this, take a and b separately. Now if you take this solution set as a, x is greater than 2.5, that is 3, 4, 5, 6, 7, infinity, because x belongs to integers is given. And this set I am taking as b, x is less than or equal to 5, less than or equal, so 5, 4, okay, x is less than, right, 5, 4, 3, 2, 1, 0, minus 1, so on, all the less values. Now a intersection b, a and b combined, solution set for both given inequation is a intersection b. Both the inequations satisfying solutions only we need to write. So both the equations satisfying solutions means common solutions in both. So when you observe, 3 is here and here, 3, 4, 5, only 3, 4, 5 is a common, and 2, 1 is all negative, these are 6, 7 big numbers, that means 3, 4, 5. So among a and b, the common solution, that is the solution set for this given inequation. So only 3, 4, 5 for this, right? Okay. So similar sum, I explain one more, some big one. See one question. Taking 0, okay, 0 less than 5x minus 12 less than 13, and here x belongs to rational numbers. Okay, x belongs to rational numbers, so not a problem. We can take the two separately. So we should take them separately and we need to solve. Now when you take this 0, right? Okay. 0 less than 5x minus 12, and again 5x minus 12 is less than 13. Separately should solve. Positive 5x if you take left, negative 5x less than negative 12. Both sides I am multiplying with minus 1. So 5x and this is plus 12, but sign less becomes greater than. Then x is greater than 12 by 5. So x is greater than, so 12 by 5 is 2.4, right? You can do division. And similarly, if you solve this side, 5x is less than 13 plus 12. So minus 12 is plus 12, and 5x is less than 25. So x is less than 25 by 5. So x is less than 5 because 5 ones are 5 5s. So x is greater than 2.4 and x is less than 5. Now this is x is rational numbers here. There is no single numbers. Greater than 2.4 means even 2.5, 2.6, 2.41, 2.42, like many infinite numbers. Now solution set for both combined is, we can write like this. So solution set to combine. So x belongs to rational numbers. Here x is greater than 2.4 means we can convert like this. 2.4 is less than x, right? X is greater than 2.4, then 2.4 is less than x, and x is less than 5. So 2.4 less than x, x is less than 5. So x should come in the middle. In that way you need to adjust. So first one you can change. So 2.4 less than x, less than 5. So x value between 2.4 to 5. All the rational numbers. There is a solution set for this. So we can solve in this. So a few more sums I'll explain here. We'll take one problem of fractions. So some fractions are there. So same sum, any problem or like this you can solve in same method, in same pattern, same steps you can follow. Okay, minus 1 less than 2 by 3x plus 1 and less than or equals to 5. Okay, here x is belongs to rational numbers. Same, whenever we have two inequalities we can apply we need to solve them separately. Okay, you can solve them separately, then you can simplify. That's simple. Now minus 1 less than 2 by 3x plus 1. First two inequations. And last two means middle is combined, right? 2 by 3x plus 1 less than or equal to 5. Now when you solve this, okay, minus 2 by 3x less than 2 by 3x is, if you take left side, minus, and this minus when you take this side, plus. Already plus 1 is here, 1 plus 1. So minus 2 by 3x is less than 2. 3 is dividing, you take side multiply. So minus 2x is less than 2 into 3, 6. Okay, 3 I took this side. Now negative 2 it is. So multiply with minus 1 both sides. That means plus 2x is greater than negative 6. I multiply with minus 1 both sides. Whenever you multiply with negative, immediately you have to change this inequation. Okay, then x is greater than minus 6 by 2. X is greater than minus 3. Okay, this is first. So when you solve this, second one, 2 by 3x is less than or equals to 5 minus 1. So 2 by 3 of x is less than or equal to 4. Then 2x is less than or equal to 3, 4, so 12. Okay, 3 take this side. And x is less than or equals to 12 by 2, that is x is less than or equal to 6. Now whenever you have 2, you can combine and write. So 1 you can change. Whenever you are getting like this, you can change 1. X is greater than minus 3. That means minus 3 is less than x. Then you can continue with this. So we can write like this solution set. Anyone, because one number should be left. Now solution set is x belongs to rational numbers and minus 3 less than x and x is less than or equal to 6. So these two combined. Right. So in this way we can solve. X belongs to Q. So rational numbers. And that implies minus 3 less than x less than or equal to 6. Right? So any problems are given, this is the way we can solve it easy. Only whenever you have two type like this, two are given, we have to separate and do. Mostly we will follow the equations rules, but only the properties, when negative multiplication or negative division only, we should interchange this sign. That's the important thing. And as I said you, the links are there in description below, and see in this website also you can find out number of solutions, including test papers, model papers. So all the subjects are available for freely. You can download and you can learn them easily, and share it with your friends, and subscribe to the channel because we'll upload only videos which are related to education. It's very useful for you and your friends.